And so now we have the third half of the midterm here for Math 151. Take the derivative of this. Well, the problem with this one is, though it looks like a power rule, it also looks like an exponential rule. We got to do it. In some ways it's both, but in some ways it's neither. The best way to do this, at least in the Calc 1 realm here, is to do it logarithmic differentiation. So take the natural log of both sides first. Oh, let's take the natural log of both sides. So natural log of this, natural log of that. I can use a property of the natural logs now and take that 1 over x out in front. So what I have now is a product, and I can handle derivatives of products. So I'm going to implicitly differentiate. And the derivative of natural log of y is 1 over y times dy dx. Right? And some people doing this a little early, they'd like take the derivative of this side and then still set it equal to that thing, and then derivative of that side, and do it all at the same time here. So now I got the derivative of this product. So I've got 1 over x times the derivative of the log of something. Well, the derivative of the log of something is 1 over that something times the derivative of what's inside. Well, in this case, the derivative of what's inside is just 1, so that was nice. And then I have the derivative of the first part. So that's going to be minus 1 over x squared times the second. And you got to multiply both sides by y, whatever this is. And then you're going to substitute the original function back in, that this y is that y. All right. So actually, I guess I did that whole problem for you. But again, if there's things you did wrong, explain why they're wrong. Did you take the derivative of the log wrong? Did you try to just do it as a power rule? It's more than a power rule. And we got 2 more to go here. Number 17. Get out of here. Find the equation of the tangent line, the graph. Okay. Well, it's possible we could solve for y and do this explicitly, but it's probably easier just to do it implicitly. So taking the derivative of both sides here with respect to x, the derivative of x cubed is, so I'm taking the derivative with respect to x of this side. I'm taking the derivative with respect to x of that side. So I've got a 3x squared plus. Now, this is a big source of error for people here. How do you take the derivative of 3x squared y? The thing is, this is a product, because with implicit differentiation, x is our independent variable, and we're thinking of y as a function of x. Well, what I have here is I have 3x and I have y squared. I have the product of 2 functions of x. So I need a product rule. So I need 3x times the derivative of y squared. Well, that would be 2y times dy dx plus the derivative of the 3x times the y squared, right? So there's a product rule there. It seemed crazy to me the number of people that I saw doing product rules when they shouldn't be doing it, and then they get to here and they don't do a product rule when they should do it. All right, so I got the derivative of that part, I got the derivative of this part, and now I need the derivative of the plus y. So that's just the derivative of y with respect to x. Okay. And then on the other side, the derivative of 15, of course, is 0. At this point, I can either solve for dy dx first, or I can plug in my points first. I'm gonna solve for dy dx first. I'm going to take the things that don't have dy dx in over to the other side. So I've got a minus 3x squared and a minus 3y squared. This is a 6xy that's still here, and there's a plus 1 there. Both of those are multiplied by dy dx. Right? I've already taken these two and factored out the dy dx, and then divide by that. Plug in the point here. So at 1, 2, dy dx equals negative 3 times 1 squared minus 3 times 2 squared all over 6 times 1 times 2 plus 1. So whatever this is minus 3, that's 4 minus 12, minus 3 minus 12, this is 12 plus 1, so it looks like minus 15 over 3, 13. That's the slope. I want the equation of the tangent line. Right? Some people got this far and just gave me the slope. I didn't ask for the slope. I asked for the equation of the tangent line. Well, I know the line goes through the point 1, 2, and I know it has this. So y minus 2 equals the slope times x minus the x coordinate. What did you do wrong? Did you do algebra wrong, moving stuff over? Did you forget the product rule? Did you not recognize the product rule, I guess is really what I should say. It's not a matter of forgetting. It's did you not look at that and see that that's a product? Anyway, and then number 18 here, use logarithmic differentiation to find the derivative of this thing. So logarithmic differentiation, you take the log of both sides first. So we have the natural log of f of x equals the natural log of all this stuff. Here's where some people messed up. This is a quotient of two things. The properties of logs is that the log of a quotient is the difference of two logs. So you need the log of the top minus the log of the bottom. I see some people just put log on the top and log on the bottom. It's like you're not dividing the logs, you're subtracting the logs. Right? This is properties of exponents. That when the exponent that you get when you're dividing is the difference of the two exponents. Then each one of these is a product. So you can rewrite those as the log of 3x plus 1 to the 4th power plus the log of the other piece. Right? And again, the people that would just put a log on the top and the bottom would also just stick a log in between those things. It's like they're still multiplying them together. It's like, no, you're not multiplying. You're multiplying these things inside. You're adding the logs outside. And then be careful here. This is minus all of this stuff. So this should be the log of x squared plus 1 cubed plus the log of the sine. And the thing is, I say be careful because with this in parentheses, this minus sign actually distributes to both of those. There's also a matter of these powers can come out in front now. This is 4 times the natural log of 3x plus 1 plus the natural log of x minus 4 minus, was that a 3? Yeah. 3 times the natural log of x squared plus 1 minus the natural log of the sine x. So this was the natural log of f of x. Now I haven't done any calculus yet. I've just done some algebra to rewrite this equation in a different form. Now, implicitly differentiate with respect to x. This side with respect to x, the derivative of this side with respect to x. Okay. 1 over f of x times f prime of x equals, and then 4 comes along for the ride, take the derivative of the log of a function, it's 1 over that function, times the derivative of the inside, the 3 comes along for the ride, the x squared plus 1 goes on the bottom, times the derivative of the inside, that's a times 2x, and likewise here, minus, you've got a sine x on the bottom, you've got a derivative of sine x on the top. You're then going to take this and multiply both sides to bring it over. Okay, so there's a lot of places where people miss things. Some people they got all the way up to here and they missed the chain rules, these extra pieces that get multiplied up on the top. There were some people that didn't get the f of x multiplied back over. There are some people, as I said, that would write this as just slip a log in here and a log in there, and a log in here. So it looks like they're still dividing and multiplying, when in fact they're supposed to. The reason we do this is it changes multiplication and division into addition and subtraction. Some people just had this minus sign as a plus sign because they didn't get that distributed into both of them. Anyway, I'm looking forward to seeing your explanations of what went wrong, and explanations of how you can convince me that you know what you're doing on these, that you've learned how to do it, and you can show me how to do it. So anyway, those are all due next Monday. Ask if you have any questions.